for a positive integer n, we define this set here. So remember that we generally write this to denote the integers. This is going to be the integers modulo n. So this is going to be all the integers from 0 to n minus 1. And also the way we do operations is going to change. So we're not going to do the typical addition and multiplication in the integers. We're going to do it differently. The way that it's going to work is we will actually add and multiply as we do in the integers, but then we're going to divide by n and see what the remainder is. So essentially we're doing congruences, right? So let's see an example. So let's say that we're working in Z6. So Z6 is going to be the integers 0, 1, 2, 3, 4, and 5. So notice there are 6 of them, and they go from 0 to 5. And now in Z6, if you say that you're doing 4 plus 5 in Z6, so 4 plus 5 in the integers would be 9, but there is no 9 in Z6. So when you divide 9 by 6, the remainder you get is 3. So 4 plus 5 is equal to 3 when you are writing in Z6. Also, as we saw before in terms of congruences, 4 plus 5 will essentially be congruent to 3 mod 6, right? Because 4 plus 5 is equal to 9, so we're saying that 9 is congruent to 3 mod 6. And if we go back to the definition of congruence, so 9 minus 3 is equal to 6, and so of course 6 divides, so this happens if and only if 6 divides 9 minus 3, which it does because 9 minus 3 is equal to 6. So in other words, when we're talking about integers modulo n here, Zn, we're just talking about the remainders, right? So it's like working with the integers, but then taking the remainders and taking the remainders that you get from the division, and that's going to be a number between 0 and n minus 1. So this is also known as clock arithmetic. And a reason for that is because it behaves very similar to how you read hours on a clock, like when you do it on the clock that has the 12 numbers. So let's see, for example, in Z4, if you write the numbers in a clock, the way that the arithmetic works is you do the arithmetic on the clock. So what is 0? So let's do the addition table and the multiplication table. So what is 0 times, so addition. When you add 0, you don't change anything, right? So every number plus 0 is going to be itself. So when you add 0 here, 0 plus 0 is 0, 0 plus 1 is 1, 2, 3, 1, 2, and 3. Okay. Now, when you do 1 plus 1, so 1 plus 1 in the clock is going to be 2. When you do 1 plus 2, it'll be 3. When you do 1 plus 3, so 1 plus 3, you go 1, 2, and 3. So 1 plus 3 is 4, but in Z4, when you divide by 4, the remainder is 0, right? And so that's why you end up at this 0 here. So this will be a 0 here. So now 2 plus 1 will be a 3 here. 2 plus 2 will be 4, which is a 0 in the clock. Because again, 4, if you divide by 4, you get a remainder of 0. And then 2 plus 3 is 5. So if you're at 2 and you go 3, 1, 2, 3, you get at the 1. And of course, 5 divided by 4 has a remainder of 1. So this will be a 1 here. 3 plus 1, we already saw, it's 4, that is 0. 3 plus 2 is 5, we just did it, which is 1. And 3 plus 3, so if you do 1, 2, 3, you end up with a 2. So 3 plus 3 is 6. And 6, if you divide by 4, you get a remainder of 2. And so that gives you the addition table for the clock, how you can add the numbers in this set for the clock. Let's do the multiplication. It's going to be the same thing. So multiplying by 0, of course, is just going to give you 0 everywhere. 1 times 1 is just going to be 1. 1 times any number will just be that number. And of course, this is symmetric. Now, what is 2 times 2? 2 times 2 is 4. But again, in Z4, 2 times 2, 4 is here, which is a 0. So the remainder of 4 divided by 4 is 0. 2 times 3 is 6. But 6 is 2, right? So because it's 1, 2, 3, 4, 5, 6, it's a 2 here. And so 3 times 2 is 6. 3 times 3 is 9. So 9, if you do 1, 2, 3, 4, 5, 6, 7, 8, 9, well, wait, did I do it right? So 9 by 4 will be 1. So I did something wrong here. So you start at 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Here we go. 9 will be this. And so this is the arithmetic, the clock arithmetic, or also the modulo arithmetic. So this is how it works in Z4. And again, the other way of thinking about it is in terms of congruences. So all of these different ways, we're talking about the same thing, but sometimes it's useful to think of them in different ways.